We have the question under circular motion, which is saying a cooling fan is turned off when it is running at 850 revolution per minute. It turns 1250 revolution before it comes to a stop. Part 1. What was the fan's angular acceleration assumed constant? Part 2. How long did it take the fan to come to a complete stop? Okay, so what we need to understand here is for us to solve this question, we need to know the relationship between the translational motion and rotational motion. Okay, so we know that the formulas which we have is v final is equal to v initial plus at. Now this is translational motion. Okay, so when it comes for rotational motion, the equivalent of linear velocity, it is the angular velocity. So it's going to be angular velocity final is equal to angular velocity initial plus angular acceleration times time. Then when we talk of the displacement is equal to v initial times time plus half acceleration times time. So the displacement, this is the linear displacement. So here when it comes for rotational motion, it's going to be the angular displacement is equal to the angular speed initial times time plus the acceleration is angular acceleration times t squared. Okay, then when it comes for this v final v initial squared plus 2, we have 2 as. This is going to be the angular final squared, the angular velocity initial squared plus 2, then you have this. Now these are the formulas which we're going to be using. So this is the relationship which is there between the translational motion and the circular motion or rotational motion. Now we need to come up with our data. Data is going to help us to know which formula is going to be suitable for us to use to get the angular acceleration for part 1. So our data is we have the initial speed, which is the initial angular velocity, which is what we have been given, the 850 revolution leave per minute. Now it's just a matter of us converting this from leave per minute to leave per second. So to convert this, I'm going to say that in 2 pilots we have 1 revolution. Okay, then times in 1 minute we have 60 seconds. So we can see that these two, they will cancel, also these, they will cancel. So what I'm going to have is I'm going to have 850 times 2 pi. The answer I get, I divide it by 60. So I'm getting 89. So this is going to be 89 rad per second. Okay, from there we know that it came to stop, meaning that the final angular velocity was 0. Okay, then from here what we need to understand again is we have been given the linear displacement. This is 100 and we have been given 1250 revolution. Okay, so to convert this to rad, it's going to be 2 pi rad divided by 1 revolution. In 1 revolution there is 2 pi rad. So I'm going to cancel the revolution, meaning that I'm supposed to say at 1250 times 2 pi. Which is giving me a 7,853.98, which is the same as 54.0 rad. So the angular displacement is 7,854 rad. So this is the only information which we have for now. Now using this information, we want to find the angular acceleration. Now it was decelerating, meaning that the acceleration is going to be negative. The only formula which doesn't have time is this. Is the angular final is equal to the angular initial squared plus 2 this, then we have this. So we have the final, which is 0 squared. Okay, the initial is 890. Okay, or it's 89 lad. So it's 89 squared plus 2. We don't know this. Then this one is 7,854. So what I'm going to do, I'll shift this to the other side. I'm going to have negative 89 squared is going to be equal to I can say 7,854 times 2, which is giving me a 15,708. So we have alpha. We divide both sides by a 15,708. Even here a 15,708. So we'll get our angular to be, it's going to be negative, okay, because it is decelerating. So we have 89 squared. I divide this one by a 15,708. So this is going to give me negative 0.504 lad per second squared. So this is the answer for part A. Now part 2 is asking us how long did it take the fan to come to complete stop. So they want us to find the time. So since we have the angular acceleration, it is okay for us to use this formula. We can use this. Okay, we can use this formula. Then you have, we want to find time. So this is going to be the angular acceleration. So the final is 0. Okay, the initial is 89, then plus the angular is negative 0.504. We want to find time. We shift this to the other side. Negative 89 is equal to negative 0.504 times t. We divide both sides by negative 0.504. We divide both sides by negative 0.504. So our time is going to be equal to, negative and negative will cancel. So our time is going to be 89 divided by 0.404. Okay, so our time, I'm getting 176.59. Now I can convert this is in seconds. I can convert this into what? Into minutes. I'll divide it by 60. So it took about 3 minutes. 3 minutes for the fan to come to complete what? To stop. So this is how you go about such kind of question. Thank you for watching this video.